Hello and welcome back to all my subscribers. And if you're not a subscriber, what's wrong with you? Press the button. Okay, so this is the second video in a series about a emulator that I'm writing. I decided to write an emulator because I'd never done one before and I just wanted to see how it was. I decided to do a really simple fictional CPU computer emulation, and it is actually quite difficult. Now, it's probably more difficult because I sort of don't know what I'm doing when writing an emulator, so that's part of the problem. But today I'm going to go through the framework expansion that's happened since the last video. I'll talk about my problem with the choice of using Python as a programming language. Now, I've run into a significant number of issues as this program has evolved, and it generally tends to be issues around the way that Python treats numbers, integers, hexadecimal numbers, strings, etc. In many cases, like for example when I defined my instruction set, I initially defined it as hexadecimal, but then when I was doing comparisons, Python was trying to compare a hexadecimal number against a string, and then I had to change that to binary, and but anyway, so it has caused me a significant amount of issues, mostly related to the way that Python works with sort of silently modifying dictionaries and things into strings or integers rather than hexadecimal numbers or whatever. But anyway, that's caused me significant issues to try and make sure everything is consistent and you're comparing like with like. So that's just quite possibly the fact that I'm not as familiar with Python as I am with C, or so that's fine. And then the other issue generally came around with the initial design of my computer, like having 8-bit registers for the I needed to change some of the register sizes, like the PC register really needed to be 16-bit, etc. There were choices around setting up a separate CPU class and a separate memory class and things like that. But I'll go through how this has evolved and try and show you what's happened. So this is the first version after my framework where I actually started doing things. Now, the first thing I did was I populated the loading of the binary file. If you remember in the last video, I showed you how I created a simple 4-instruction machine code text file, which I converted to binary. Well, this loads that. So in the command line interface, you type load and the name of the file, and this is what it does. It loads this file. Now, the first thing I discovered was that I needed a place to load it, and so I had to create a find an empty memory slot so that it loads it into the first empty memory, which is fine. But I also had to create a lot of the things for changing directories, listing directories, etc. I did a directory class because I was attempting to do something like that is like you can do in an FTP server, where you can basically lock a user into a folder and its subfolders. That really didn't work very well for me, but this is just the way that things go. But for the most part, it did work. It loaded things into memory, and I could use this mem command that I had written to basically just show me the memory. But not in this issue. This happened in the second emulator. So in the second emulator, what I did was I wrote a a function that let me see the memory. So this mem command, and display memory information. Oh, maybe I didn't do it here, but anyway, at some point I did do so I could see the memory being loaded after it was loaded. In this particular one, this sort of version 2, a lot of the things were populated. So in the first version, most of what I did was in this command line interface, and I tried to implement a lot of the load and then run the loaded program. This didn't work, but this is because of the way that I've written the classes. So this had to change. But in the second version, I populated the functions and the instruction set. Now you'll notice I created the instruction set here initially with a 16-bit hexadecimal values. This is where I ran into problems with comparisons, and so later on you'll see that this instruction set changes to different values. But one of the first things I did was I populated the execute instruction. So this is to execute a single instruction that is passed in. I did the load immediate. So I populated the load immediate. I populated the add so that it would add what was stored, the values in 2 registers. And I implemented the jump command because I needed it to be able to end the program. I need to jump to the end. And then I implemented the fetch and execute program. Now, I said I needed to jump to the end. You'll notice up here I created an end marker address. So basically, my jump instruction jumps to the end marker address and it halts the program. If you look at this closely, you'll see why this is a problem when the operand is only an 8-bit value. But I discover that later. Now, the vast majority of this time was spent in the emulator section rather than the command line interface section. So but you can see here I still have these 2 classes for the CPU and for the memory. They will go away later because they just were of no use to me whatsoever. So I didn't really do any work down here, and nothing happened in this section. Now I'm going to move on to the changes that were made in Emulator version 3, but before I do that, let me talk about my channel. I'm not sponsored. I don't have any revenue from YouTube, but I am an author and I do write books, and I'd like to talk about my fiction books briefly. If you go to my website, xgipublishing.com, fiction and non-fiction. In the fiction, you can see all of the books that I've written, and if you click on them, you can see where they're available to purchase, Amazon or Kobo. If you click this link, it'll take you to the Amazon page, and you can purchase this book. Now, I would appreciate it if you had a look at the books, and if you like them, buy them. It's a win-win. You get a book that you can read, and I get a bit of money to carry on doing what I'm doing. So this is basically a bit of self-sponsorship. So have a look if you have time, and please buy a book if you're interested. Thank you very much. So moving swiftly on, we close the sponsorship and we move back to Emulator version 3. Now, version 3, I had to configure logging because troubleshooting this was becoming a nightmare, and I needed lots of logging. So I implemented the Python logging, And I removed the classes for CPU and memory because they just weren't of any use whatsoever. Now, at this point, things were not going to plan, and that's the reason for all of the logging, because it was not executing the 4 instructions. So I put a lot of logging in to see what, if anything, has changed in the registers, and nothing had changed. It wasn't hitting these jump logs, so it never actually outputted this into the log. So I couldn't figure out what was happening here. It just didn't seem to be reading the instruction set properly. It just was not going to plan. Now, part of the problem was the run. You remember before I did run program, that didn't work very well. So I went back to the command line interface and I implemented a new thing called an interrupt flag. And I initialized the emulator in a thread all by itself, and it just has the interrupt flag set to true, which means it halts it. The thread's running, but there are no programs running in the emulator portion. So that was fine, but I did need to see what was in the memory. So at this point, I did implement a memory address. Now my program only loads 4 instructions, and so I only needed to check these addresses. But this is the major changes that were happening here. Again, another register just to display, and added in the stack pointers and the flags into the register information so I could see what, if anything, was changing in the system. I reworked the load file a few times, but actually this works. There was nothing wrong. It was loading it in, and I was able to see it correctly loaded in the system, but it just was not processing the file properly. Now, and it wouldn't halt, it wouldn't stop. Now, a bit of a spoiler, remember I said these are 16-bit hexadecimal values, but I'm not trying to compare 16-bit hexadecimal values when I'm looking at these instructions, right? And so this is part of the problem and the issue that I had with this. So I scrapped that. I went to a version 4, but version 4 didn't work very well, and I eventually worked on version 4.5. So version 4.5, if we go back up, there is still a mistake here, but a part of the problem I had was the threads would not stop. I actually had to go in, do a PS, find the actual Python script and kill it to get it to die. So I had to fix the threads so that I could exit the emulator. You'll notice that my halt instruction is still 16-bit. So if you see the error, you know what's happening, or one of the many errors. Now, the other thing is you'll notice the instruction sets changed because I did discover, okay, Python has converted these things to strings, and so I need to be checking strings against strings, not hexadecimal values. So I changed the instruction set so it stores these as strings, so I can do proper comparisons of my dictionary when I do it. So I convert the opcode into a string, and then I compare that string to this string, and then that works out way better. So I've been doing, in this version, there was just hours and hours of troubleshooting and modifications, mostly around the fetch and execute. Now, fetch and execute is the thing that should read the instruction from the memory, separate it into opcode, registers, and then the final 8 bits of operand. That's what it should do. That's what it eventually did. and then it should stop. And if you look at this, you'll see why it didn't stop, because the operand is a 8-bit value and the end marker is a 16-bit value. So that was one of the problems that I had to overcome. It was not going into the jump. It was not showing up in any of the actual commands above. So for example, I had logs into the jump instruction, and I should have seen it in the log files, but I never did. So it was never actually getting into this function. So significant amount of issues. So I needed more debugging in the command line interface. So not just logging, but I needed to actually see what was happening. So I added things in like step command to step through things, the logging mode, obviously, registers, which were okay. They already showed stack pointers and things, but then I put in breakpoints, clearing breakpoints, and then I did a change to the mem command, so that rather than just a fixed amount of memory, I could get it to display memory within a range. So it wasn't just those 4 memory addresses. I could look through all of them if needs be. So this particular one was heavily involved in troubleshooting and trying to work out how to view what was going on within the emulator, in addition to looking at the logs and trying to work things out. Now, I have worked out a lot of problems. I'm currently working on version 5, and a lot of the things that I've pointed out I have corrected. I've discovered and corrected and fixed. I'm still having issues getting these 4 instructions to run in the order in which they should run. So, this emulator isn't as easy or as simple as I thought it was going to be. However, I'm learning a lot. I mean, I am amazed at the amount of stuff that I'm learning from doing this, and I do recommend that you get yourself a project like this and try it and see how far you can go. Right, that's it for this video. I can't tell you what will be in the next one of the series, because I don't know really how far I'm going to get, or even if I'm going to complete it. But I will do another one and at least show you version 5 and how far I've got, and whether I'm going to quit or not. But I'm going to try and power through this and get to the end. Hopefully you'll follow along. If you like these sort of videos, please like and subscribe and share them. And I will see you in the next video. Thanks a lot.